So in this video, I'm going to look at the atoms and what the numbers and what the symbols actually tell you when you look at the periodic table. So here we have sodium, and I can see that there's a number 23 above. I can see the symbol Na, and I can see that there is another number which is 11 underneath. But what does that even mean? Well, what you should know is the blue number at the top is called the mass number. Now, the mass number tells us the number of protons and neutrons which are present within an atom of that element. So in this case, the mass number is 23. Now, the red number, 11, is my atomic number. Now, that's telling me the number of protons that I have. So if I know that I've got 11 protons, that therefore means that I must also have 12 neutrons because my mass number was those two added together. So then I can also figure out that actually I have 11 electrons because my number of electrons equals my number of protons, because as an atom, my atom is stable. So therefore that tells me, because it's in group 1, I also know that there is 1 electron on the last outer shell, and that's all that I'm representing here in my diagram. So now let's look at chlorine then. So chlorine is a different element in the periodic table. Chlorine, I can see, has 35.5 as its mass number. I can see that it's got 17 as its atomic number. So what does that tell me? Well, that tells me that there are 17 protons present, and therefore I also know that there are 17 electrons present because my atomic number also equals the number of electrons present. So I know that atom has that. But now I know that the mass number is my number of protons plus neutrons. If I minus 17 from 35.5, I don't get a whole number. So I'm going to tell you that we know that it's group 7, therefore it has 7 electrons in its last outer shell. But we know that if I minus my 17 from 35, I would get 18 of my neutrons, or 20. Well, this is because chlorine actually comes as an isotope. There are 2 versions of chlorine. And when we talk about different versions of chlorine, we actually call them isotopes. And what we're saying is the elements with the same atomic number, so they both have 17, however, they would have different neutron numbers. So chlorine can either come as chlorine with a mass of 35, or it can come as chlorine with a mass of 37. Now, what we would do when we're looking at isotopes is we would actually bring that together and divide it by the percentage that is present. And that's why we get a number which is 35.5.